All right. So greetings to everyone in the museum and those of you on Zoom, and happy Valentine's Day. You can tell who didn't buy flowers today. So we just missed another snowstorm by 2 hours or something like that. So we got to make this, we got to be done at the right time for this one. And just a reminder that we're a volunteer organization. None of this would be possible without generous donations. And again, I'd like to thank Heather Sontag, our tech support. She's our secretary for our organization and also does the tech every month for this. So, and it's always a little different. So I'm Dan Halling. I'm on the board and I organize this series of lectures, and they run monthly on the second Wednesday of every month through May. Our next lecture will be on March 13th. Ori Eilertson, current vice president of the Badger History Group and a longtime local historian, will speak on the Kingston Cemetery and the Freethinkers Hall. Kingston was the name of this township before the Civil War, and then it was renamed Sumter. And the cemetery is still there. Well, you don't really move cemeteries usually. The cemetery is there off from Highway 78, on just outside of the fence, and the Freethinkers Hall's been gone for quite a long time now. But Ori will fill us in on that next month. So join us again on March 13th, 7 o'clock. You can check out all of this on our activities page for badgerhistorygroup.org, and also on Facebook at badgerhistorygroup/BHG. Those on Zoom, just reminder to mute yourselves and keep your video off if possible, because that improves our broadband access. So, and please hold your questions until the end. And for those on Zoom, type them into chat. We'll ask them for you. So in order to introduce our speaker tonight, Frank, I have a short story to tell you. It was the best of times and it was the worst of times. It was the French Revolution. And there were 3 people to be executed by the guillotine in one morning. The first one was a lawyer, and put his head down, pulled the pin, nothing happened. They said, well, we don't want a big lawsuit. So they let him go. Next one was a priest. Same thing happened. They said, well, this is divine intervention, and they let the priest go. And the third one was an engineer. And as they led him to the block, and just before he put his head down, he looked up and he said, I think I see your problem there. So Frank is a chemical engineer with nearly 6 decades in the energetic material industry. I believe that means things that go boom. And really, to read his resume is incredible, and it takes quite a long time. But one thing that stood out to me was the year I was born, 1966, you began your training in the Panama Canal Zone. He'd been all over the place. So if we want him to speak, I'm not going to share much more about his resume, but he was Chief Modernization Engineer at the Badger Ammunition Plant for 31 years. He's currently our treasurer for the Badger History Group Board of Directors, and he's been involved in local history, especially his hometown of Maizomanie, written, I think, 7 books on that, right? And that and local genealogy at Mazo, right? So one thing I appreciate about Frank is, and this is unlike a lot of people, surprisingly, He doesn't talk if he doesn't have anything to say. There's a lot of people that don't follow that rule. In this case, I'm pretty sure he has plenty to say and show us. So this is Frank, I think, fourth lecture for our group, fourth or fifth.
Something like that.
Yeah, and probably 4,000 or something like that for your career. And he will focus on ball powder production tonight. And as usual, we are certain to have a blast and get a bang for our buck.
Okay.
From Frank. Okay. Got it.
Thank you, Fred. I want to thank you all for coming tonight. Those people that are here, those are on the internet. Yes, I'm Frank Wolf, the third one out of 5. And I did work for Badger a long time as a chemical engineer. And when I was putting this together tonight, I realized that it's been 55 years since I first started working in the ball powder area. So my information is kind of old, and maybe it's not quite like other people remember it. Now I remember it certain ways, but I keep seeing new things that jog my memory again, and it's a little bit different. And so I hope you learn a few things tonight. I sometimes have trouble with technical subjects and getting it to people that aren't technical people. So sometimes I've been accused of being too technical. But just bear with me. That's the way I is. If I ain't got nothing to say, I don't say nothing. Ain't that right, Fred? First, I want to tell you how we made ball powder. This is sort of the synopsis of what I'm going to talk about. This is how we made ball powder at Badger in the old days. First, the lecture content will be something about ball powder. Then it'll be about the Badger ball powder area, the various buildings and the production record. And then there'll be a description, a not so technical description of the manufacturing process at Badger. Then there'll be a lot of pictures of the various buildings and the equipment. And I have a lot of slides, and some of them will go real fast when all there is just a picture and a few words. And some of them are very busy, so I'll try to give you a little chance to take a look at them. So that's what we're going to be talking about tonight. What is ball powder? Ball powder is a double base propellant made from nitroglycerin and nitrocellulose. Those are the 2 main ingredients. It was invented by Olin Corporation's Fred Olson in 1936. So it's a fairly new propellant compared to some of the black powder and things like that. It's nearly spherical in diameter, and the diameters are from 20 to 30 thousandths, very small little particles, 20 to 30 thousandths inches. The size is very important parameter. There has to be this mixture of certain sizes in a certain size range. All has to do with surface area of the propellant. And since ball powder was made in an agitated solution in a tank, it is very stable compared to solid propellants. It has been known to last up to 40 or 50 years. So very stable propellant. And there are currently more than 100 different types of ball powder propellant. We only made a few of them here at Badger. Here's a picture of ball powder. It is loaded into the back of that back end of that small arms cartridge there. I don't know the exact caliber of this, but that's what makes the bullet. That's what makes the bullet. You have an explosion in here with this the propellant, and out out goes the bullet. That's what makes the bullet move. And with these kinds of small arms, you want every single shell to fire at the same speed. So you want the same explosion going on in here. And that's where the tricky part comes in, making sure every single cartridge explodes exactly the same way. Timing is important when you got these very fast ammunition. Everyone's got to be exactly the same. And it's easy to make ball powder that way. Ball powder is a batch process here at Badger, 500 to 10,000 pound batches rather than a continuous process. There are no chemical reactions in this process, just mixing, collating, evaporations, and phase changes. And there's a lot of buildings involved here. The ball powder plant was built in 1954 to 1955 during the Korean War. They built it within a year. There's an awful lot of buildings. You see a picture here to be built in a year. Ball powder ingredients. Here's a listing. As I mentioned before, it's double base, nitrocellulose, 40 to 70%, depending on what kind of propellant you're making. Nitroglycerin, 10 to 45%. But the more explosive got more nitroglycerin in. Then there's a deterrent, 5% ethyl centralite, and that's added to control the burning rate, how fast the explosion happens. Dibutyl phthalate, its colloid, is added to help form the lacquer solution that makes these little round balls in the hardening stills. Then there's a stabilizer, diphenylamine, that's added to prolong the shelf life. Keeps all the ingredients stable so it'll last that 40 to 50 years. Then ethyl acetate, that's used as a solvent to make the solution of nitrocellulose and nitroglycerin. And then there's some more minor ingredients, chalk, salt, and graphite coating to make the propellant balls slide and move around easier. This is a very simplified little process diagram of the Badger process. It's much more complicated than this. There's a lot of recycling stuff going back here. That size, small stuff and large stuff goes back and starts over here. The same thing here goes back and starts over. Drying and finishing, there's an awful lot of stuff going back and forth here, so that end up with a stable product coming out that's exactly the same as everything else that came out. So there's a lot of other, for lack of a better word, lines here. This is a simplified one. It is simplified into these 4 major steps. The hardening process, that's where the nitrocellulose here is dissolved with ethyl acetate into a lacquer. Lacquer is like a muddy solution, and then it's dissolved and it forms into little round balls as the agitator agitates this solution. Then it's separated into different sizes for various types of powder, and then the next step, dissolves, is where you put the nitroglycerin into the coating on the little round balls that you made. Then you also add stabilizer. Then the balls are rolled to make a same surface area over all the different types of powder. And then it's dewatered so you can get it dry. And the last major step is the drying, adding graphite, blending the final product, and then packing it out. So we take this very complicated process and break it down into these 4 major steps. These are the 5 types of ball powder that were made at Badger. They only made these 5 types. Remember, this is first time they're really commercializing ball powders. The first 2 were what was made the most of, WC 844, the 5.56 cartridge. I'm not sure if what 5.56 millimeter and the 7.62, one or the other is the NATO standard cartridge, and the other is the US military standard cartridge, but I never remember which one is which. But those are the 2. We also made some propellant for other larger caliber, 30, 50 caliber cartridges and the 20 millimeter cartridges. And it's always interested to me, how did they ever arrive at these numbers? And I don't know the answer to that. I do know that Winchester cartridge is what the WC means. And they still use, 50, 60 years later, they still have these same damn numbers. The modern ball powder plant down at St. Mark's, Florida, which is the only one in the United States where they make ball powder nowadays, they still use these numbers, only they got a whole bunch of other numbers. At Badger, to summarize, we made WC 844 and WC 846 for 5.56 and 7.62 millimeter cartridges. How much ball powder did we make? The year after the plant was built, during the Korean War, we made 5.8 million pounds that 1 year. Then the 9 years during the Vietnam War, we made 100 million pounds. Now that sounds like, to me, it's always a round number like that, but that's what the number is, 100 million pounds. But this is still only 1/3 of what Badger's capacity could be. And the best I could figure out from calculations is Badger could make 36 million pounds a year. And that's more than the current St. Mark's plant can make today, except that they make a whole bunch of different varieties. And we only made the 5. 36 million pounds. That's a lot of railroad cars full of powder. The ball powder plant shown here in yellow. Here we're right here right now. And here's the rocket area, the magazine area. Here's the big bend in 12. It's right in this area, right in the center of the plant, and it's about a mile and a half by a mile. Here's a picture of the ball powder area. We are right at the bend in the Highway 12, looking towards the north. The building we're in is up in here. And here's where the ball powder area starts, right through here. Here are the hardening houses, or the weigh houses. And there's the hardening houses. There's the screen house, the big tall building. And then here are the coating houses. Here are the nitroglycerin buildings around the coating houses. This is the western end. Then this next slide shows the eastern end of the ball powder area. We all know this is the Baraboo Bluffs. Here's the office buildings in here. There's that screen house. There's the coating. Here's the finishing area through here. I want to go back to here. There was one major incident in the ball powder area. And there's supposed to be 3 of these hardening houses. Well, there's one here, and then there's a open area here where that used to be. So they haven't rebuilt it yet. But that's where the explosion was, right in here, where one of the hardening stills exploded. And supposedly, well, it is known, during the explosion, a 50 horsepower motor off of one of the pumps flew through the air and landed in the office building right here. But that's where the incident happened, in the ball powder area. And all this hazy stuff here, that is not pollution. No pollution here. Okay, now let's talk about individual buildings. The first process building, the weigh house, a 2-story concrete and steel building. There's 3 identical ones like this. And in the back is the hardening house, pipeline connecting the two. Concrete and steel buildings. In the weigh house is a nitrocellulose water slurry is dewatered in this machine, dewatering, where you weigh the nitrocellulose into 10,000 pound batches, put it into a solution, water solution, and then pumped over to the hardening house. This is some of the weigh house tankage. And 2 operators run this house. It's all fairly modern piping, tankage, although this is a wooden tank. This tank here. Here we're inside the hardening house, up on the 2nd floor. There are 8 of these hardening stills, and the hardening still is back here. It's got this, each one has a control panel. Here's 1, 2, 3, 4, and then over on the other side of the building is another 4. And each of these batch stills has an agitator, that shows better in the next picture, and a distillation column. And 6 operators run this house. Now this is I'd say 1960, 1970 control panel. And they don't build them this way today. An operator stood here and made adjustments here, and then there's valves here, and he turned and opened things up, kept track of the temperatures and the agitation speed and things like that. And the distillation temperatures, all controlled individually right here by an operator standing here, and then monitored with these old style recording devices. Now the nitrocellulose in the hardening still is dissolved in ethyl acetate. The diphenylamine is added. Nitrocellulose solution is carefully broken up into these little lacquer particles for the desired size and shape by controlling the agitation speed. See here, you have an agitator in the middle here, baffles and so on inside the still, and you use the speed of those agitators on how big or smaller you make the little particles. And salt is added to take the water out of these little particles, making them hard little particles. And there's a very specific recipe for doing this. Then once the little balls are made, you got a tank full of little particles that look almost exactly like the finished product. Then you evaporate off the ethyl acetate. You can reuse that ethyl acetate to make another batch. Here's the hardening still with the manhole open. And after the you'll harden the 10,000-pound batch. You pump the product out of here into a wash tub where it's washed, and then it's pumped over to the screen house. And this whole hardening process takes 10 or 12 hours. And every batch is not quite the same. It's processed a little bit different depending how the results as you're processing it, how long it takes to do certain things. Everything you want to make the end product exactly the same, but each batch is a little bit different. And when I first started doing this work, 55 years ago, me and Ted Weston, we used to spend a lot of our time fooling around with these recipes. If we change the speed a little bit, what does this do? If we distill it a little bit longer, what does this do? All kinds of fooling around. So it's almost like cooking a casserole. Exactly how you do these things. And we had a big sheet of paper with all this data on it, making these minor little adjustments to make the product a little bit different. To me, it was not very chemical oriented. It was more like cooking, which in a way it sort of is. And here's the first floor of the hardening. These are the tanks that are down below it. A resin where you wash off the residue, salt, the deterrent, and the ethyl acetate. The screen house. Large screen house, 120 feet high. We're looking towards the east from the west, towards the Wisconsin River. The first floor is covered with large 42 different concrete tanks here, full of these various sizes of powder. Here's another view of it where we're looking towards the south. And we're separating the raw powder into 7 different sizes. The 7 different sizes to control the ballistics as we blend it, the different sizes together. Screen house screens, looking from the bottom up towards the top of the screen house. 3 different screen lines, a lot of piping. See right here, there's a screen, here's a screen, another screen here, another one up here. Here's the top of the screen house. Here's the three different screen lines, 1, 2, 3. Each screen has only 1 screen on it. You're only making 1 separation. There's the overs and the unders. There's not some types of gyratory screens like this got 5 or 6 different versions. Here you're only separating top and bottom. Then the top goes over into the next screen and the bottom drops down into one of the tanks down below. And these are Rotex screens from about the 1950s and 60s, but they still make them this way today. Only they got their the gearing in here is all much more modern, but these work pretty good, and they're hung. They're all hanging.
What are those screens made of? What are the screens made out of? Steel?
You name the metal and they've tried it, but they're mostly stainless steel nowadays. But they got various versions. And then they changed the wire sizes, and they changed how they weave the wires together, depending on how much open area. It's a lot. It takes a lot of fooling around to get the right stuff, especially when nowadays when they have 3 or 4 different screens in the same screen. Another picture. You see there's a screen here, another one up here. Stairways, it's all open. I like to go up at the top because you can look up the top and you're 150 feet in the air and you're 100 25 feet in the air, and you're looking down, and you can see the tankage down below, and it's all open under here. And then you got these screens gyrating, so the building is sort of, so it makes you want to hang on to something. And this gentleman here, I thought when I first saw this picture 30 years ago or so, I thought that was Larry Hudak, but he looked too young. Then I thought it was my mentor, Ted Weston, but and he didn't look old enough there. So I don't know who this is, but he's a supervisor of some sort, because all supervision people wore these kinds of coats, glasses, and a hard hat like that.
It's not you then.
Who?
It's not you then, huh?
I hadn't thought about that. I suppose, yeah, back then I wore black glasses. You might be onto something there, Paul. That could be me. Thank you. I hadn't thought about it that way. I'm looking for somebody else, but I guess that could be me. I've got to show my wife this. She'll know whether that's me or not back then. Here's the bottom of the screen house. I was talking about these large concrete tanks, and the whole bottom was full of these tanks where the products from the screens went into, and then they were pumped from various places from here over to the coating and so on, and were blended into other buildings. Picture of the coating house. Here's the coating house, another concrete and steel. Then around and there's two of them, and around each building are these little buildings with the barricades around. That's where the nitroglycerin was stored.
What was that stored in? The nitroglycerin?
Ethyl acetate, which is pretty safe, but still nitroglycerin. You got to keep remembering that. Here's a coating still on the second floor of, again, it has a large control panel. There are 4 coating stills in each one of these coating houses. Same size still as the hardening still. Got an agitator here, evaporation column, and then you have this fancy control panel. Operator here with his recipe again on how to put the coatings in. Each house had 3 operators in it. Here's another view of the coating still with the agitator, and you see the motor up here for the agitator, evaporation column. And coating operation also takes about 12 hours. As mentioned, it's got a very detailed recipe on temperatures and agitation speeds. And nitroglycerin is added with ethyl acetate, impregnating into the grains. Then the ethyl acetate is evaporated off. The deterrent ethyl centralite is added near the surface to control the burn rate. That goes on the surface of each of the little particles. Then the charge after the 12 hours is dropped into a wash tub, a wooden wash tub, and washed. Here's a picture of the bottom floor where the completed charge is washed. Here's the bottom of the coating still, wooden wash tanks. Roll and dewater house. Got 3 operators in it. 2-story concrete and steel building. And now up until this product was coming in here in water solutions. And now we're gonna be handling it with with the tram tracks, tram, railway. Flaking rolls, powder is rolled in these rolls. Products come in here, dropped in here and dropped into the rolls. There's two of them here. That's rolled to increase the surface area to control the burning rates. Surface area is extremely important to burning rates. So they make every single particle, every single propellant charge the same. After it's been rolled, it's run through a bird dewater centrifuge. And you're taking a water solution and putting it down to about 10% water in this centrifuge. Then it goes to the tray dry house. Wooden building, 2 dryers per house, 1 at each end. And 4 operators operate each of the houses. And now it's being handled by 500-pound charges. Batch charges. Here's a dryer tray cart. And you put trays of propellant in here that's all manually loaded. Whole bunch of trays in here. You take this cart and you push it into this area here where the hot air is blown into the dryer itself. That's outside air. It's heated from the outside, heated up and blown in there. And it is dried down to 0.1% moisture, 0.10% moisture. These are wooden buildings. Pre-blend sweetie barrel. Everybody knows what a sweetie barrel is. That's where you sugarcoat candy. Well, in the ball powder process, is used to put stuff on the surface coating of the ball powder propellant particles. Now the finishing operations are quite complicated. A lot of recycling and blending stuff together to get the right combination for the blistings. And so there's a lot of recycle and reworking of the propellant. There's many powder rest houses. And one of the operations is this pre-blending in the sweetie barrel. In this barrel, powder is salt and graphite coated and blended with rework. So these manually dumped in here and swirled around and dumped out into these 500-pound charges. Final blend house, 2-story wooden building. There's 4 operators and 1 blending barrel. Notice they got these escape chutes off the 2nd floor. So if something goes on, you quickly get out of here. And here they're got little tram. It's actually like a little tractor pulling a couple of carts with these 500-pound circles of propellant, pulling them around between buildings in the finishing area. There's a final blend barrel, zigzag blender, another type of blender than the sweetie barrel. Powder was dumped in here and then this circular around blending. Pack out house, a wooden set of 2 buildings. These 500-pound steel circles of powder loaded into the overhead conveyor over here on this end, goes up to the conveyor into the pack out building where there's a scale and shipping boxes, which are they're loaded into down below here. There's a couple operators in here, and this is their escape chute to get out of there. The final pack out house, all wooden buildings, wooden barricade. Direct labor to make ball powder. 105 people per 8-hour shift. This is at Badger. 105 people required to make ball powder. This does not include the overhead and laboratory people like that. Number of the direct operators takes 105 people, an 8-hour shift to operate the plant. And when you do the calculation, it comes out to 25 man hours per 1,000 pounds of powder. A lot of labor. But then when you think about it, 25 hours per 1,000 pounds, that ain't too bad. Except St. Mark's now, that number is about 1/3 that at the modern St. Mark's plant. Now, a couple of weeks ago, I was asked when I heard about making this presentation, somebody wanted a comparison between the modern process nowadays and the ball powder process from Badger in the old days. So here's a comparison. Here's the processes, the major pieces, the 5 major pieces. And here's what we did at Badger. And here's what it is at St. Mark's, the modern plant nowadays. To me, the biggest difference is the hardening, making little round balls. Here at Badger, we had this batch still, made into batches in a still. At St. Mark's, they have a continuous process where it's really an extrusion process, making little round balls. Then they have a long rounding where they pump it around and around for a couple 100 feet to make all little particles round and run. So that's the biggest difference. Batch system, continuous system. And of course, along with all this is at St. Mark's, there's a couple of guys sitting in the control room, which is a separate building, running the whole operation. Whereas at Badger, they had individual people standing at each still operating the plant. Size separation is still screening, except Badger's geometric screens. At St. Mark's, they have an old-fashioned underwater circular tumbling screen, obsolete in 1910, but they use it because it works for them. Because you're screening such small difference in particle sizes. The coating is still done with batch. Modern control systems, but still batch. The drying, where at Badger they had a tray dryer, individual manually handling tray drying, where at St. Mark's it's a continuous fluid bed dryer. That's another big change. And the finishing is still batch. They still got sweetie barrels, pretty big ones though, but still got sweetie barrels. A lot of rest houses, very large ballistics laboratory, keep track of all this stuff. And that's all I have. I want to thank you for your attention and hope you learned a little bit about how they used to do it in the old days here 150 years ago. 55 years ago. Do we have questions?
Put the slide up with the overview, looking at the buildings and show us where, again, now where those buildings are that you described. Yeah,
These are the hardening houses, or the weigh houses, where the charge are weighed up. Here's the hardening house, where the particle is made, little round balls. Here's the size separation, where they have the 7 screens in there, separate into 7 different size particles.
Can you also say how how it was transported between each building?
Oh, here it's water slurry. This is water slurry. Size separation is again water slurry. See the pipelines here? That's all water, all this is water slurry. Some people call this the wet side. Okay, here we are with the coating buildings. That's a water slurry to the dewatering and these buildings here. The finishing area, and then all from here on, it's all dry powder.
So it's what are those last buildings for then again? Is that rest houses? What?
Yes, there's rest houses in here. A mixture of rest houses, blending houses. But most of it's rest houses where a batch is sitting, and the laboratory people have all this data, and they tell you what to mix together to make final product. Then they do the ballistics to see if that's what really it is. Then they give the okay to ship. In the real, I've been accused a few times of telling people the secrets, because there's a lot of secrets to making ball powder. But to me, the real secrets are how you take this product that's different, all different, and blending it together to make a product that is exactly the same all the time. A lot of these things are not patented. As soon as you patent something, then the world knows. And I've been accused of showing somebody something that's our secret. But if nobody tells you this is a secret, it ain't no secret. Like you got a secret color to your glasses. You got the only kind of glasses in the world, and you don't tell anybody that, nobody knows. Yes.
How did weather affect all that in Wisconsin between 20 below and 105 degrees or 12 inches of snow to?
I'm sure it did, but I specifically, I don't, do you know, Paul, how the weather?
I don't think there's anything much different in color, but it certainly changed how you had to do things.
Yes.
Well, we had on those days, or when you expect them days, the crews come in and they be plowing at 4 or 5 in the morning, whatever, which is quite a while before I got there. But, yeah, and some people really had it tough. There were some women out there pushing them in single base, pushing them trays from one building to the other down basically a sidewalk. And that was going on all the time. That was sort of one of the cool things. Other than nitration house, that was bad. Not so much the weather, but what you had to breathe, because you pretty well nitrated your lungs while you were in there too. I visited there, and that wasn't enough.
Frank,
Yes.
we have a comment from your photos. I think it's this one. It might be the other one, but Michael Gock says, note that in the left foreground of this photo are the barracks that were used for worker housing in the 1950s.
Oh, yeah.
Yes.
Later for Conservation Club, now Dairy Forage uses one survivor.
Yes, these are
Thank you, Mike. Go ahead.
There, right there's what Mike's talking about. These,
Oh, the H-shaped foundations.
yes,
And there's a shooting range there to the right there.
Yeah.
And
and people could have breakfast with your neighbors with a wall between you and talk. I mean, it was very primitive buildings that you lived in. Not much insulation.
I lived across the street, which was about the same situation. And one time I heard neighbor next door, this is probably 10 or 11 o'clock. You see that? It's at 10 o'clock in the morning and you want a beer? Well, no.
And this area in here is where the dairy forage is talking about putting their new facilities where they're expanding. And again, right here is where that explosion happened with the hardening still. This is the buildings that Mike's talking about.
I think you take that hardening house and right to the left and up a little ways is the office probably.
Yes, right
I
here.
think there was a motor went through that front.
Yep.
That was, I don't know, 4 or 5 months before I got there. I came in 67.
I hadn't mentioned anything about it, but right here, this building here is part of Ball Powder also. That's where you took old propellant, old gunpowder, and extracted the nitrocellulose out of it so it could be made into ball powder. So they took old gunpowder from World War, I heard of World War I even, 1 and 2, and extracted the nitrocellulose out using benzene and other chemicals.
Getting the DNT out mostly,
Yes.
extracting it out with all things benzene, but whatever.
Yep.
Is that the only place they did that? I mean, was that the only facility that?
I think
Yes.
Ben's was, it was an old one back.
Yes. This is an olden method that they still use it at St. Mark's. A process similar to this.
Frank, do you know the caliber used in the M16 rifle?
223, yeah.
Can you say it louder so that the people?
223 caliber.
223 caliber.
We had the one, I think, 846, and I don't know what caliber, but that was one that was rolled. And I think we rolled it to about 150 thousandths. And, yeah, and as I understood it, that was for cold, really designed for cold weather. Because he rolled it, cracked it, but when it was exposed to cold weather, it would crack more and it would get the pressures up. Because everything, it's all a surface burn. Everything happens on the surface. So if you have a cold, it cracks more, you get a little more surface. So bring the pressure back up where you want it.
I think that 556 is the 223. And the 7.62 is the 308. Yeah. Still used as hunting rifles.
Can you repeat the
So
second?
when the
one?
ball powder was
7.62.
shipped out, where did it go?
What?
When the ball powder, you said it was shipped out, where did it go for
It probably went to Lake City ammunition plant
our process?
to get the actual put into the cartridges. We did not load any cartridges here except for ballistics.
What did you say, Lake City?
Lake City ammunition plant.
Where is that?
Where's Lake City?
Minnesota.
Missouri. Oh, yeah, maybe.
Oh, there is a Lake City, Minnesota.
Yeah.
It's placed on the Mississippi and Illinois. It's been long closed down too.
There was the Olins Corporation,
They were down in
East Alton. I think some of it might have went there. No, they made their own there.
No.
Can you go back to that aerial photo one more time? I just want to remind people that if you go to, you're talking about those barracks, you just look at Google Maps, especially the Google Maps that just came out on the computer, you can see the footprint of all those
Yeah.
those barracks still
Mhm.
from currently.
We have a question from Carolyn Dahlman. How significant was Badger ball powder during the Vietnam War?
Okay.
It was the
It's
most.
very, yes, it was
Could
it.
you repeat the question for Zoom people?
The question was, how significant was ball powder during the Vietnam War? And my answer would be extremely significant. There was talk about the rifle jamming up. And they used to blame ball powder for that. But it's my understanding you had to keep your rifles clean, or they're gonna jam up no matter what kind of propellant you use. But ball powder is, to me, very clean comparatively. Yeah, it's got graphite on it. And graphite is, but you gotta have the graphite so that it all rolls together and moves around smoothly.
One of the other coatings that went on that place at the time, and some of the blends was with potassium nitrate in it. And that was to control flash, as I understand it.
Uh-huh. Now, that's another good thing about ball powder. It doesn't make a big flash like other propellants do, so that it doesn't leave a signature. You can hide in the bushes and shoot, and they can't see you with a flash where the gun's being fired from.
Thin dioxide, some of that, high pressure lubricant.
Yes. Any other questions?
I
Oh,
got
yeah, there's
one.
She just said. What percentage of ball powder used during the Vietnam War came from Badger? Do we know? Do you know offhand?
I would say most of it, except the only other place. Remember, there's only 2 places that make ball powder in the United States
During the Vietnam War?
during the Vietnam War.
Okay.
Is most of St. Mark's production going to the government?
No,
So we were it.
yeah, we were sort of it. There might have been a little bit St. Mark's.
Yeah.
Yes,
Where was some of the initial ingredients purchased or sourced from, like the cellulose and?
Well, cellulose is micro pulp.
yeah, we made that ourselves. That was made here, or it was extracted from this old powder. But most of it was made here. Nitrocellulose was made here. On our nitrocellulose.
Is carbon fiber, right?
Mm-hmm.
Yes,
So where did that come from?
Well, we had pulp. We got pulp in more, I don't know I guess there was some cotton linters, but,
Wood pulp?
yeah, so it would come from whatever paper mill to make it.
Okay.
yep, it looks like a,
Good, nice bleach stuff.
it's like,
4 pounds.
when it starts out, it looks like a big roll of paper. You know, one of those big rolls of paper that are 3 foot in diameter, 5 feet. Comes in here and they shred it all up and then nitrate it, make nitrocellulose.
That's that place where they're talking about the nitration house. Yeah, it's pretty rough on people.
See, these are these buildings in here.
Up towards the front of the plant there, huh?
Yeah,
Well, show them how bad it is. It was brick buildings, because it was a wood building, it would nitrate the whole.
yes.
You have a question?
Yes, Fred.
How long did it take usually for finished material to be shipped off from the property completely? How long did some of that powder sit in magazines? In the magazine area?
Other people have asked me this question. It's a tricky one to answer because of all this recycle.
Mm.
The answer I usually say is between 1 and 2 months to go through the process. from when you weigh it up, when you pack it out. Now, some particles or some batches are gonna go right, fairly fast. Others that for some reason they weren't quite within specs, that could take 2 months to blend off. So there's all this blending going on that makes the answer kind of, and you can come up with some median averages and so on, but I'd say 1.5 to 2 months, something like that.
Basically, if you couldn't blend powder, you couldn't make powder.
Yes. Yeah, if you relied with no blending, you ain't gonna do it.
You look at the chemistry and then you see if that's okay, and then you deal with ballistics. And that's what makes and breaks.
Yes. The ballistics, which has to do with all the various particles that went into it, the size of it, surface area. Bang, their bang's gotta be the same every time. And if it ain't the same, can't use it.
You don't want the bullet to go.
Did you test fireball powder at Badger? Michael Gock asks.
Oh, yeah, all kinds of ballistics. And I would say that's probably the most important part of the whole deal. If you can't make ballistics, you can't make it.
So you check the product at the end.
Oh, do we check the product? Yes.
And where did that take place and who executed it?
Well, it was Badger. I mean, we did like Paul. It was Badger people, and there was a ballistics range way over there where there's one company still has the rocket people. There was a ballistics range there where they had all the fancy firing ranges and how fast and what the explosions was. I mean, that's extremely important. Well, it's probably the most important thing for making ball powder is.
There was a lot of testing going up the whole line. And 3 blends and circles and then 3 blends. And batch blends. And batch blends were checked out for ballistics. And that determined when you had a hand blend. And they put whatever batch blends together, samples of that to make a hand blend. And that, if it turned out right, it's what they mix up and then they take a sample for the government testing. And initially, while I was in the powder lab, there actually was 2 buildings, a powder lab and what's called the government lab. In the first operation, which is World War II, the government tested the final product. In Vietnam, we actually tested the final product under government supervision. We tested the final product chemically and well, it would have been for the ballistics too, same type of situation where they tested ballistically for acceptance purposes.
You have a question?
Nope. I'm just gonna see if there was any more. So we're done, we're wrapping things up. I think we could ask a lot of questions for a long time. So I think we got our brains pretty full tonight. Frank, thanks a lot. And make sure to come back next month on the, what did I say, the 13th? Oh geez, I just looked. The second Wednesday of March, and we'll hear from Ori. So thank you, Frank.
You.
Yeah.